BGP path selection. We learned that selection of path is not based on any metrics like bandwidth or delay or hop count. It is purely based on the policies that we enforce using attribute. And we saw different categories of attributes, and we saw differences between those attributes. Attributes like weight, MED, local preference, AS path, next hop, origin, we have discussed. Those are the attributes that we can tune. The other attributes are used in path selection dynamically. For example, there is an attribute called EBGP path preferred over IBGP. So when there is a tie in all that we have learned yesterday, there is tie in all the attributes that we have learned. And if you are not going to do a tie break by configuring, it will choose the path which is an EBGP neighbor path instead of IBGP neighbor. For this, you don't have anything to do here. It's dynamic. If you don't have EBGP, then closest IGP. What you will do here? Maximum we can go and tune the OSPF, because closest IGP to choose different path. You need to tune OSPF metric here. So we don't tune those attributes that comes after this MED. All those things are dynamic. The oldest route to the destination, the router ID of the neighbor, the neighbor's IP address. All this we are going to see now. Iteration happens against this list that we see right in front of us. If a router learns a route, it learns with next hop. But if the next hop is unreachable, tuning all this attribute is useless. Very first minimum attribute that needs to be valid is a reachable next hop. See, BGP uses TCP protocol, so advertisement will come to you as a BGP update delivered to you as a TCP packet with some next hop address. It's well-known mandatory attribute, so it should be there, otherwise it's not a valid update. It will be always there, but sometime the next hop address will not be a reachable address. Then it is of no use. The update is of no use. You can't use it. You cannot go to the destination whose next hop is unreachable. So when we have an unreachable next hop, when we have an invalid next hop, then configuring all these attributes is of useless. It's a waste. So make sure you got a valid next hop before you tune any attribute. So you can call that as the 0th attribute. Routes with valid next hop. In what circumstances we will get a next hop unreachable? In what situation we will get a next hop unreachable? So usually route learned from one IBGP router. When an IBGP router learns route from another IBGP router, the IBGP router will not put its own address as a next hop. It carries the address given by EBGP. This is what next hop behavior in BGP. What is next hop behavior? When an IBGP advertises a route to another IBGP, it advertises without putting its own address as a next hop address. It will simply carry the next hop given by EBGP. Anyone needs more explanation for this? I can do that. You might have forgotten those fundamentals in BGP. Next hop behavior. If you're comfortable, then I'll move further. Okay, looks like you're comfortable. Fine. So when we have valid next hop, and if you have two paths to a destination, two different paths via two different autonomous system can take you to a destination, and both paths have got a valid next hop. Based on the weight, you can choose one path and ignore the other. So if you are not going to tune, then it will it will do the iteration against this list 1 to 11, and sometime it may choose based on, it depends on the topology. Okay, it will do based on attribute 8 or 9 or 10 or 11, or sometime based on 4, shortest AS path. But if you say that this router will not go via right hand side, it will go via left, then you need to set high weightage to the neighbor in the left. We saw what weight attribute means. If you want router A to go via the neighbor in the left, then you need to give more weightage. But make sure B and C both are giving a valid next hop, the 0th attribute. Then only the weight that you set will be working. Otherwise it won't work. Next, if you want the entire autonomous system to go via left instead of right, or go via right instead of left, the entire autonomous system should go via right hand side. Then set the local preference higher on the router which is connected in the edge to the right hand side autonomous system, like local preference 200. But if weight is set in a router, local preference will not be effective on that router. All other routers we will follow the local preference except that one router, because on that one router the very first attribute is the tiebreaker. Only when there is a tie in first, it will come to second. Fine. When there is tie in second one, the local preference, only then it will try to use the third attribute, which says prefers the route originated by local router. See, when the network is advertised locally on the same router, the next stop will be what? See, it is advertised locally, not from real any next stop. It is local. So next stop will be 0000. When the next stop is 0000, automatically BGP will give the high weightage. So attribute 1 will kickstart. Attribute 1, you see, let me show you one sample. There is no sample here. Here is a sample. See. This network, next stop is local. For this, 32768 weightage is given, not manually, dynamically. You no need to give this. It will be automatically given so that this will be preferred instead of going via some other neighbor router. For example, if you see this subnet, you have locally this network advertised. You also learn the network from another source. Which one is preferred? If you see star and gray than symbol, this is preferred. Locally is preferred because of the high weightage. So attribute 3 will use attribute 1 to give a preferred path. Now if there is tie in all these three, the path with the shortest AS, means what? Prefers the path with shortest AS means what? The number of autonomous system in the path should be less. If you see this picture, to go to this autonomous system, if I go this way, 1, 2, 3 hops. If I go via this way, it is 1, 2 hops only. So when we don't have local preference, when let's say local preference is 100 on all direction, and there is tie in local preference and origin and weight, when there is tie in the attributes that we have seen here up to 3, when there is a tie in the this first three attribute, it's going to pick the shortest AS path. So it won't go via A. Instead, the packets will exit via B to reach this network. Shortest AS path. Next is prefers the lowest origin code. Origin means what? Taking birth. Code. So there are two ways in which a network will take birth into BGP. One, we advertise the network inside BGP using network command. The other way, we redistribute the routes. These are the two ways in which the network will originate. The origin code for advertised network is I. That's why it is called as internal to BGP. internal to BGP, because we use the network command to advertise. We don't have this protocol anymore. There was once a protocol called EGP. And then incomplete means what? Redistributed routes. Smaller is preferred. Which one is small? I is small. R is I. Using network command, the network is advertised. Lowest origin code. Next. Prefers lowest MED. So again, I want to remind you, only when there is tie in this 5, it comes to this, but it doesn't mean that this will be a tiebreaker. Why? For MED, there's a special environment needed. You need to have 2 connections to the same autonomous system. Look at this, like this, MED. You cannot have 2 different autonomous systems. If for this, the upstream is 2 connections to the same autonomous system. Only then the traffic will get inside via the router whose MED is lower. The default MED is 0. So we go to router A and say 150 for router B. We don't configure these things on this router. As I said earlier in the previous class, we configure this here in router A, and that will get advertised to router B and C, and it will reflect on B and C. This is for the packets that enters the router A's autonomous system. This will impact the incoming. See, MED is used to advertise to eBGP to say how to exit their autonomous system. How can you, router A is telling, how can you, B and C, can exit your autonomous system to reach my autonomous system in order to ping my network. So this is one attribute which impacts the incoming. All the other things that you have seen above, they focus on outgoing. Outgoing, which exit I need to take. This is the one which focuses on incoming. Now again, for this attribute to work, you need to have a dual home, not multi-home. Dual home scenario. What is dual home scenario? Connection to same autonomous systems. More than one connection to same autonomous systems. Sorry, autonomous system. That is dual home. If you don't have dual home, then attribute 6 will not be effective. When we have multi-home, means connecting to 2 different autonomous systems. Or more. No need to be always 2. It can be 3, 4, 5. I have seen 5 autonomous systems as eBGP neighbor. So in such situation, you will have the 7th attribute now. Attribute 6 will not be effective because you don't have dual home. So when you have multi-home, if one of the router is showing you next stop as eBGP neighbor and the other route is showing iBGP neighbor, then prefers the eBGP path. This is also dynamic. What if both are iBGP, there is no eBGP? Then it prefers the closest, what if both are eBGP No, sorry. What if both are IBGP neighbors? There is no eBGP. If one is eBGP, one is IBGP, it would have gone via eBGP. If both are IBGP, what to do? Need to see which IBGP router cost is lower. You may be running EIGRP or OSPF to reach that IBGP. Internally, you will be having a IGP protocol. So the closest IGP neighbor will be taken. This is also dynamic. If you want to tune this, then you need to tune your OSPF only, not BGP. For BGP to decide, you need to tune OSPF because it depends on the closest IGP neighbor. Closest IGP is determined using the IGP protocol like OSPF, EIGRP. If you don't understand when I do the lab, you'll understand this. Next. Prefers the oldest route for eBGP path. Prefers oldest route. If there is tie up to 8, it prefers the oldest, means the route that was learned first. See, there are two neighbors giving you route. Which neighbor gave you the route first? That is the oldest one. So prefers the oldest route for eBGP path. Prefers the oldest route for eBGP path. Next. Prefers the path with the lowest neighbor BGP route ID. So this cannot be a tiebreaker actually. Sorry, this can be a tiebreaker always, because definitely there cannot be a tie. One eBGP neighbor or one neighbor will be having lower router ID than the other one. Router IDs are unique, no? So only when there is tie in the first 9, based on the router ID, see, lowest, you should not understand, it's not highest router ID, lowest router ID. The neighbor whose router ID is lower is preferred. For which attribute 9 should say there is no old route or new route. Both the routes have come the same time. Same time. The same milli-micro time. Which is very difficult. If it is seen, then only it is going to be based on the router ID. Now, assume an assumption. Pretend. Imagine that our routers, our neighbor routers have got same router ID. Not possible. But assume the neighbors have got same router ID. Then it is going to choose the path with the lowest neighbor IP address. IP address of the neighbor, can that be same for two neighbors? Not possible. IP address will be definitely different. So there cannot be a tie after this. There may be tie even in attribute 9, attribute 10. That is also very, very thin chance of getting that. Even if there is a tie in those things, there cannot be a tie after attribute 11. Prefers the path with the lowest neighbor IP address. Ask me a question, no?
I don't know.
Yeah, please go ahead.
So you were saying only one will be chosen over the weight or local preference, right? So that means basically only one has to be configured on the router.
No, you may configure all of this, but it will check whether weight is a tie. If it is not a tie, then why should I go for local preference? It won't go for local preference. So even if you configure all those attributes, it is going to pick the attribute, it is going to decide the path based on the attribute which is a tiebreaker in this order.
Okay.
If weight is a tiebreaker, the local preference that you have configured is waste on that router. If local preference is a tiebreaker, then it won't go to this one, third one, route originated by local route or AS path or origin code, any of this. So, for example, you did not do any attribute configuration and traffic is going because of the shortest AS path via one path. Dynamically, it is deciding to go via attribute 4, as per attribute 4, that you don't like. If you don't like, then you can go and configure attribute 2 to overcome the dynamic path, to override the dynamic path and have your own path using the local preference. So if you don't have a policy, then it is going to be based on the dynamic iteration. If you don't like the dynamic iteration, then you go and set your own policy in path selection using the attributes that we learned: weight, local preference. AS path can also be tuned, MAD, so on. I'm going to do these labs and show you, then you will understand this much better. Okay, more question.
Yeah. So, can it be opposite also, like A in the top and B and C in the down?
Same story. A in the top and B and C in the down. Then you are going to configure on A and it will impact in B, down.
Okay. It's not on the upstream only, right? It can be given form in the... Okay. Thanks, sir.
You're welcome.
Hello.
Yeah, Murli.
So, Aaron, I have question. Let's say in this scenario, ABC, we have 3 locations, okay? So BGP path
Wait. These 3 are not 3 locations. These two are eBGP neighbor, a very adjacent router, and it is not 3, it is 2 only. 3 routers. Okay. 2 routers are from one autonomous system.
Okay. Okay, so my question is, for the path selection, let's say if I have 3 from A to B, A to C, so I have 2 neighbors, B and C. Right, so the selection process, let's say if I have all the parameters, MED, local preference, weight. Okay. So how we will define the policy as which our wanted, right? So as per the requirement, we will define the traffic, right? So my question is, path selection, how that depends on the neighbor router? Is it go and see and coming back?
No. When you analyze the traffic that is coming inside router A, you found that most of the traffics are coming from C, which you don't like. So what you do is, you set high MED for the neighbor C, so that automatically you will see traffic switch to B and it will come from B. You analyze in your router, you don't need to go there and see and come here and configure. No, not necessary. From your...
Okay. So we are doing only BGP config. Let's say if I take A, what is coming and what is going, that is what we need to define, right?
Yeah, that's all your job is. how my traffics are going, how the incoming traffics are coming in, and if I don't like the way that it goes out and comes in, then I'm going to tune the attribute to get the way that I want. Yes.
Okay. So the path selection, if can you go to the slide, path selection? Yeah. So let's say if I have all parameters, okay, weight, local preference, this all.
You
so
configure, no?
Yeah. So this configuration, let's say if I have, the BGP process will take decision based on local router or all the routers in the AS. EBGP.
Local router.
Okay, so
on each router this will be checked.
Correct. So in that case, the 10th point.
10th point, see, that is also local. I am receiving, I means local. I am receiving 2 neighbor advertisement. One of the neighbors router ID is 1111, the other one is 2222, so I prefer to go via the neighbor whose router ID is 1111. I only decide on my router based on the update coming inside me.
Okay.
Right. Any other question? So, BGP metric is called as the path attribute and describes the path to reach each network. These attributes are categorized as well-known mandatory, well-known discretionary, optional transitive, optional non-transitive. We saw that in the previous class. The AS path attribute is well-known mandatory. What is the other example for well-known mandatory? Next hop. AS path attribute is well-known mandatory attribute that lists the AS number that the router has traveled. So the router has traveled to reach this destination. BGP next hop attribute is also well-known mandatory attribute that includes the next hop IP address to use to reach the destination. The origin attribute is also well-known mandatory attribute that defines the origin of the path information. Local preference is another attribute that we learned, which is global to the autonomous system. It's well-known discretionary attribute because it may be present, may not be present. That's why it is discretionary. The local preference attribute is a well-known discretionary attribute that provides an indication to routers in the AS about which path to prefer to exit. Exit is what the keyword here. Whereas MED is how the packet enters. See, MED attribute is called as metric. MED. Actually, MED is not metric. MED stands for multi-exit discriminator. The MED attribute, also called the metric, is an optional non-transitive attribute that is an indication to eBGP neighbor about the preferred path into the AS, coming inside. The MED is sent to eBGP peers. Those routers propagate the MED within the AS. The routers within the AS uses MED but do not pass it to the next autonomous system. What does that mean? If me, one autonomous system, if Murli is another autonomous system, I set MED and send to Murli, but Murli will not send to Pradeep. That is what it means. Murli is third autonomous system from me. So the MED that I set will go only to Murli and Murli's routers. All the routers in Murli. So MAD is sent to eBGP peers. Those routes propagate the MAD within their AS. The routes within the AS uses the MAD but do not pass it to the next AS. Weight is an attribute which is local to the router. Higher weight neighbor is preferred. It is used only when we have multi-exit to the same destination, and it is defined by Cisco. Paths for the network that are determined not to be the best are eliminated from the selection criteria but are still kept in the BGP forwarding table. Of course, yes, all the paths will be seen in the BGP forwarding table, but only those that are selected will be put into the routing table for reachability. BGP follows the multiple step process which we just saw when selecting the best route to reach the destination. Right, so this chapter is the important chapter. And the following classes we are going to have this demo, one attribute after the other. We're going to have demo. That will give you much better understanding on how these attributes can be used. So today we stop here.